Hello, and welcome everyone. Today, we are tackling the LeetCode Daily Challenge for June 24, 2025. The problem is called Find all k-distant indices in an array. If you are new to arrays or LeetCode, don't worry, we will walk through everything, step by step. Let's start by understanding the problem statement. We are given an array, nums, which is just a list of numbers, and two integers, key and k. A k-distant index is any index I in the array, where there's at least one other index j, such that the value at j equals the key. That is, nums j equals key, and the distance between I and j is at most k. That means the absolute difference of I and j is smaller than equals k. Our goal is to return all such indices I, in increasing order. Key insight. A k-distant index, I, doesn't need to contain the key itself. It just needs to be within k positions of any index, j, where nums j equals key. Let's make this concrete with some examples. Suppose we have the array nums and the values of key and k, as shown on the screen. First, let's find all the indices where nums j is key, which is 9. We see that nums is 9 at index 2 and index 5. So, the key indices are 2 and 5. Now, for every index I in the array, we check if it's within k equals 1 distance of either of these two key indices. Let's go through each index. For index 0, distance to index 2 is 2, which is greater than 1. Distance to index 5 is 5, which is greater than 1. Thus, index 0 is not a valid k-distant index. Index 1. Distance to index 2 is 1, which is smaller than or equal to 1. And the distance to index 5 is 4, which is greater than 1. Since at least one, index 2, is within k equals 1, index 1 is a valid k-distant index. For index 2, distance to index 2 is 0, which fulfills the criteria of being smaller than or equal to 1. Distance to index 5 is 3, which is greater than 1. Since at least one index, the index 1 itself, is within k equals 1, so index 2 is a valid k-distant index. For index 3, distance to index 2 is 1, which qualifies the criteria of less than or equal to 1. Distance to index 5 is 2, which is greater than 1. Since at least one index, the index 2, is within k equals 1, index 3 is a valid k-distant index. For index 4, distance to index 2 is 2, which is greater than 1. Distance to index 5 is 1, which is equal to 1. Since at least one index, the index 5 is within k equals 1, index 4 is a valid k-distant index. For index 5, distance to index 2 is 3, which is greater than 1. Distance to index 5 is 0, which is smaller than 1. Since at least one index, the index 5 itself is within k equals 1, index 5 is a valid k-distant index. For index 6, distance to index 2 is 4, which is greater than 1. Distance to index 5 is 1, which fulfills the criteria of being smaller than or equal to 1. Since at least one, index 5, is within k equals 1, index 6 is a valid k-distant index. So, all indices except 0 are valid. The output is the list containing the indices 1, 2, 3, 4, 5, 6. Let's try another example. Nums, k, and key are as shown on the screen. Here, every index has the value 2, so every index is a key index. That means, for any index I, it is always within k equals 2 of itself and every other index. So, all indices are valid k-distant indices. And our output will be 0, 1, 2, 3, 4. Let's talk about the approach. We find all indices where the value equals the key. Then, for each index in the array, we check if it's within k distance of any key index. If yes, we simply add it to the result. Basically, we make sure we know where all the keys are. Then the code checks every index against every key index, but as soon as we find one that's close enough, we add it and move on. We ensure no duplicates, and only add each index once. Let's now look at a simple C++ code. This is the entire C++ code, but we'll be looking at it in parts to understand it better too. Basically, we make sure we know where all the keys are. Then the code checks every index against every key index, but as soon as we find one that's close enough, we add it and move on. We ensure no duplicates, and only add each index once. First, we have a helper function, called check for key. This function takes the array and the key as input. Inside this function, we create a list called list_of_j, to store all the indices, where the value equals the key. We loop through the array, and whenever we find that nums I equals key, we add that index I to our list. Now, let's look at the main function, called find k distant indices. First, we call our helper function, check for key, to get all the indices, where the key appears. We store this in list_of_j. Next, we create an empty list, called residential, to store our result, which is the indices that are k distant from any of the key indices. Now, we loop through every index I in the array. For each I, we check every index j in list_of_j, where we have the indices where the key appears. For each pair, we check if the absolute difference between I and j is less than or equal to k. If it is, we add I to our result list and break out of the inner loop, since we only need one valid j for each I. This approach is efficient because we only scan the array once to find all the key indices, and then for each index in the array, we check if it's within k steps of any key index. If you think about it, if there are no key indices, our result list will be empty. If the key appears everywhere, then every index will be included in the result. Let's talk about the complexity of this solution. The time complexity is big O of n into m, where n is the length of the array, and m is the number of key indices. And the space complexity is big O of m, because we store all the key indices in a list. And that's it. This is a straightforward problem once you break it down. If you found this helpful, don't forget to like and subscribe for more LeetCode solutions. Leave a comment if you have questions or want to see more problems explained. Thanks for watching, and happy coding.